This is the Calculus Pre-Lecture Series. My name is Caitlin Murphy, and in this podcast we'll be talking about trigonometric identities. First, we'll recall the unit circle. A unit circle is just a circle with radius 1 centered at the origin, so here we have one pictured. And we're also going to recall three of our trigonometric functions. We have sine of theta, cosine of theta, and tangent theta. A common mnemonic for remembering the values of these functions is SOHCAHTOA. We have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Coming back to our unit circle, if I pick a spot on the unit circle, say right here in the first quadrant, I can draw a right triangle by dropping a perpendicular down to the x-axis and connecting my point here to the origin. Here's my right angle. And I'll label this interior angle theta. Okay. And notice the hypotenuse of my right triangle is a radius of my unit circle, which means the length here is just 1. So if I wanted to calculate the sine value of this theta, sine theta is opposite over hypotenuse. My opposite is this y value right here, opposite over hypotenuse, but the hypotenuse is just 1, which means my sine value is just that y value. So right here, this is just sine of theta. Similarly, if I wanted to calculate the cosine value of my theta, I have adjacent over hypotenuse, but the hypotenuse is 1, so adjacent is just going to be my cosine value. So this x value right here is just cosine of this theta. To connect those two together, we have tangent is opposite over adjacent, which means tangent of this theta will just be sine of theta over cosine theta. Now we'll recall the Pythagorean theorem. The Pythagorean theorem says that if we have a right triangle with sides A and B and hypotenuse C, the following relationship holds: a squared plus b squared equals c squared. So let's recall from the last screen, I have my unit circle pictured here in the bottom left. If I take a point here, I can make this right triangle. I'll label my angle theta. And then I remember this y distance is sine of theta, and this x distance here is cosine of theta, and my hypotenuse is just 1. So if we connect these two ideas, the Pythagorean theorem, with the definition of our sine value and cosine value for our right triangle in the unit circle, we have this relationship: sine squared of theta plus cosine squared of theta equals 1 squared, which is just 1. And this is the first in a set of 3 identities that we call the Pythagorean identities. Now we'll look at deriving the other 2 Pythagorean identities. So over here on the left, I have sine squared of theta plus cosine squared of theta equals 1, which we derived in the previous screen. If I want to derive one of the other Pythagorean identities, I say, what if I divide this entire equation by sine squared of theta? So I have to divide everything on the left and everything on the right. And that leaves me with sine squared over sine squared is just 1, plus cosine squared over sine squared. That's the reciprocal of tangent squared of theta, which is cotangent squared of theta. And then 1 over sine squared of theta, the reciprocal of sine squared of theta is cosecant squared of theta. So this is our second Pythagorean identity. If we want to derive the third equation, we'll do a similar thing, but just divide everything by cosine squared of theta instead. So on the left here, we'll divide by cosine squared of theta. And on the right, leaving us with sine squared over cosine squared is tangent squared of theta, plus cosine squared over cosine squared is just 1, equals 1 over cosine squared of theta. 1 over cosine squared of theta is just secant squared of theta, which gives us our third Pythagorean identity. So all in all, our Pythagorean identities, we have sine squared of theta plus cosine squared of theta equals 1. 1 plus cotangent squared of theta equals cosecant squared of theta. And tangent squared of theta plus 1 equals secant squared of theta.